Here's a video for Notes 4-1, translations and reflections. So let me start with some definitions. A rigid transformation is a transformation on the plane, there's a typo there, on the plane that preserves length. In a rigid transformation, the pre-image and the image are congruent, which means the same size and same shape. So when we say preserves length, we mean we're not changing the size or the shape of the image. So a couple other definitions. A pre-image is the original point, shape, or line before the transformation, and the image is the new point, shape, or line formed by transforming the pre-image. We use prime notation, which is this apostrophe after a letter to indicate the image. So if we look here, we have this triangle ABC. This is the pre-image because it's the original figure. Some type of transformation happens and it becomes the image, and we would label that triangle A prime, B prime, C prime. So in this lesson, we're going to specifically talk about two types of rigid transformations. The first rigid transformation, is called a translation. And a translation is a transformation in which a point, shape, or line is moved without changing its size or orientation. So essentially what we're doing is we're taking a figure and we're sliding it. So let's take a look at an example. It says, draw and label the image produced when triangle UVW is translated 2 units left and 6 units down. So essentially what we're going to do is we're going to take every single point and we're going to translate it 2 units to the left and then 6 units down. So looking at U, we're going to go 2 units to the left and 6 units down. 1, 2, 3, 4, 5, 6. So my new point, we're going to label as, let me use a darker color. We're going to label as U prime. We're going to do the same thing with V. We're going to go 2 units left, 1, 2, and then we're going to go 6 units down, 1, 2, 3, 4, 5, 6. This is my V prime. And then lastly, W, we're going to go 2 units left, 1, 2, and we're going to go down 6, 1, 2, 3, 4, 5, 6. W prime. So now I have my new figure here, which I'm going to actually highlight just so we can see it a little better. So as we can see, our new figure, U prime, V prime, W prime, is the same size and shape as the original. So there's another way that we can actually write this transformation. It's called using coordinate notation. And to do that, we're basically saying, what did we do to every x coordinate? We moved it to the left 2, which means we subtracted 2 from every x coordinate. And then what do we do to the y unit? We moved it down 6, which means we subtracted 6 from every y coordinate. So this is another way here that we can express this transformation. So this is translating it or expressing it in words. This is expressing it in symbols. All right, let's look at example 2. So example 2 is using that coordinate notation. So it says, translate quadrilateral VWXY, x minus 3x, oops, this should be y minus 5. So in words, let's describe what this transformation means. So since we're subtracting 3 from every x coordinate, that means we're going to go left 3. And then since we're subtracting 5 from every y unit, that means y coordinate, we're going to go down 5. Okay, so let's go ahead and do that. So we're going to go down or left 2. It actually doesn't matter which order you go, but we're going to go left 2, down 5. 1, 2, 3, 4, 5. So here's x prime. Left 2, down 5. 1, 2, 3, 4, 5. Here's y prime. Left 2, down 5. 1, 2, 3, 4, 5. W prime. And then V, left 2, down 5. 1, 2, 3, 4, 5. V prime. So here's my new figure. I labeled my coordinates using prime notation to indicate that that is the image. So luckily with translations, they're relatively straightforward, and that we can do this without using a coordinate plane. We should just be able to do the transformation and find the new points just by the description. So in this particular one, it tells us that we have a triangle TSR with these coordinates, and we're going to translate it 5 units to the right and 1 unit up. What are the coordinates of the image? Well, we could write this in coordinate notation if we wanted. 5 units to the right means that we're going to do x plus 5. Since we're going right, we know that that's positive. And 1 unit up means we're going to add 1 to the y coordinates. So taking my original points, which is, so t is 1, negative 1. My new point, we're going to add 5 to x, which means my new point is going to be 6, comma, and then we're going to add 1 to y. Negative 1 plus 1 is 0. So t prime is going to be 6, comma 0. Now I'm going to take s. My original coordinates is 0, 4. We're going to add 5 to 0. So 5 plus, or 0 plus 5 is 5. And then we're going to add 1 to 4. 4 plus 1 is 5. So s prime is going to be 5, comma 5. And then lastly, for my third point, r, the original point is 4, comma 2. Using my transformations, I'm going to add 5 to 4 since we're going to the right. So that means r prime is going to be 9, comma, and then we're going to add 1 to 2. 2 plus 1, that gives me 3. So r prime is going to be 9, comma 3. Okay, so now let's talk about reflections. So reflections is a transformation in which a point, shape, or line is flipped over an axis of symmetry, creating a mirror image of the pre-image. So we're going to be reflecting over horizontal and vertical lines, although you can reflect over any type of line. They could also be diagonal, but we're going to just do horizontal and vertical lines. So when we have a horizontal line, we know that that looks something like this. And horizontal lines are always going to be written in the form y equals something. Wherever it crosses on the y-axis, we write it as y equals something. For vertical lines, so we've actually already seen horizontal lines when we've been talking about asymptotes. Vertical lines look like this. And they're always written as x equals something. And that something is wherever it's crossing the x-axis. So let's take a look at an example. It says, draw and label the image produced when triangle UVW is reflected over the x-axis. So first of all, let's figure out where our line of reflection is. So it says the x-axis, and our axes are labeled, but x, remember, is the horizontal axis. So let's do that reflection. So we know that we're going to reflect it over, which means that we're going to flip it, which means that the image down here is going to be a mirror image of the figure, the original figure, the pre-image. So if we were to fold the paper along our x-axis, all the points should line up. So to figure out what the mirror image is, we're just going to count how far away each point is from our line of reflection. So looking at U, it is 1, 2, 3, 4 boxes away from our line of reflection, which means its reflected point is also going to be 4 units away. So 1, 2, 3, 4. Here's U prime. Now W is 2 units away from my line of reflection. That means W prime is going to be 2 units away on the other side. And then lastly, V prime is 1, 2, 3, 4, 5 units away, which means V prime is going to be 5 units away. 1, 2, 3, 4, 5. So here's V prime. So here's my reflected figure. As we can see, this is a rigid transformation, so it's the same size and the same shape. So in the box, it says, compare the coordinates of the pre-image to the image. Well, I'm going to write out the coordinates of my pre-image in green. So U, the coordinates were -1, 4. V, my coordinates were 4, 5. And W, the coordinates were 4, 2. And now I'm going to write the coordinates of my image. So U prime, the coordinates were -1, -4. V prime, the coordinates were 4, -5. W prime, the coordinates were 4, -2. So here's just a little challenge here. We saw in the previous, with translations, we can write the transformation in what's called coordinate notation, so in terms of x and y. We can actually do the same for reflections. So a reflection over the x-axis can be written as, well, as we see, if we compare our pre-image and our image, if you notice, all of the x coordinates are the same. So when writing this in coordinate notation, we know that x stays the same, but if we compare our y coordinates, the y coordinates are all opposites. So 4 became -4, 5 became -5, 2 became -2, which means we can express that as -y. So reflection can be written as x comma -y. And that should make sense because we reflected it down, so it became on basically the other side of the coordinate plane. So from that, we can probably extend and think, okay, well, what would a reflection over the y-axis look like? In that case, we're reflecting it to the left. So the y coordinates are going to stay the same because they're going to be on the same level, but the x coordinates are going to be flipped on the other side. So reflection over the y-axis can actually be written as -x comma y. This isn't something you necessarily need to know, but just as a little extension for those of you who want a little bit of a challenge. Okay, let's look at another example. So it says, draw and label the image produced when a quadrilateral VWXY is reflected over the line y is equal to 1. Okay, so this case, it's not an axis. In this case, it is a line, and in particular, we should recognize that y equals 1 is going to be a horizontal line. So let's go ahead and draw on our paper where the y equals -1 would be, and that would be right here. So this is my line of reflection. Okay, and I know that because it crosses here at y equals -1. So this is y equals -1. So to do the reflection, we're going to do the same thing we did before. Every point should be the same distance away from the line of reflection. So to plot y prime, it's 2 units above, so that means my new point is going to be 2 units below. V prime, same thing, 2 units, so we're going to go down 2 units. W prime is 1, 2, 3, 4. So we're going to do 1, 2, 3, 4. And then X prime is 1, 2, 3, 4. So 1, 2, 3, 4. So here's my new figure, my new quadrilateral. As we can see, same size, same shape, just a different location, different orientation for reflections.